In this video, we're going to study how to graph polar equations. And we're going to start with simple equations. One of the easiest equations that we can graph are those that has this form. R, let me put it further to the right. R, it's equal to a value times cosine of theta. Or also we can explore what happens when R it's equal to a value times sine of theta. So the thing is this. We have a couple of conditions here, and those are if A it's greater than 0, what happens, right? If I have a positive number multiplying the trigonometric function. If we have that A is less than 0, that means negative. If it's negative, what happens? If it's positive, what happens, right? This is what we're analyzing. It turns out that you already know this because, I mean, if you watch the previous video about how converting polar equations from polar to rectangular, we already know that this type of equations are circles, right? And we can review that in a second, right? So if we're dealing with cosine, and A is positive, we're going to get a circle. But if it's positive, the circle is going to be drawn to the right, okay? And it's going to touch the pole. That circle is a little bit, all right, let me try again, right? It's going to pass through the pole, right? And if it's less than 0, that means that it's negative. Then if it's cosine, then the circle is going to be drawn passing through the pole on the left side. So it's going to be something like this, okay? And for sine, if A is positive, the number that multiplies sine is positive, we're going to get a circle. But that circle is going to pass through the pole, but it's going to be on top. Okay, let me draw it properly. It's going to be here on top. Okay, and if it's negative, you probably guessed it, it's going to be a circle, but we're going to have it on the bottom, passing through the pole. Also, we're going to need a little bit of information. Okay, to find, if you remember, circles has radius. To find the radius, we're going to take that A, or the absolute value of A, and this is for everything. So the radius is going to be equal to the absolute value of A divided by 2, right? That will be the radius. And we know that the center will be here, and the radius will be this piece. So for each one of this graph, this will be the absolute value of A divided by 2. That means positive A, if you remember, always positive A divided by 2. And that will happen here too, right? That will happen here too. And that will happen in each one of these equations. Understood? All right, let's make the graph of one of the equations that we already studied in the previous video. Let's graph R, it's equal to 2 sine of theta. Okay, so immediately we notice that A is positive and that we're dealing with sine. So if it's positive and we're dealing with sine, we know, and let's graph this, we know that our graph must be over here, right? It must be on top, okay? But we need a little bit more information. So the radius, we already know it's going to be the absolute value of 2, that is 2, divided by 2, that is 1. Okay, so we already established that this is a circle because it's just a number multiplied by sine, right? So it's going to happen through my pole, right? And it's going to be a radius of 1. So the diameter is going to be twice as that. So it's going to be 2. So I got 1 and 2. So I know that my circle, and let me draw it a little bit bigger so you can appreciate it better on your screen. So we have 1 and we have 2, right? So this is my diameter. My circle ends here. This is my center. And obviously, I'm going to have, this is 1, this is 1, 2. 1, 2, because the radius is 1, so the distance must be equal to all those points. So if I try to graph this, then I should get around that circle. Let me try to draw it better with a different color. So it should be something like this, a little bit better, yeah, passing through the pole, remember. So that is my circle. If you use a compass for this, it will be like a perfect circle. Okay, let's do another problem. Let's graph R equal to 4 cosine of theta. 4 cosine of theta. So actually, let's do it with negative. Negative 4 cosine of theta. What happens is if it's negative? Okay, so remember that we need to find the radius. So the radius is going to be, let me write that out properly, the absolute value of 4 divided by 2, but the absolute value of 4 is 4 divided by 2 is 2. So the radius is 2, right? And we know, let me graph my polar grid here. Okay, we know that since it's negative, and we're talking about cosine goes on the right or on the left. But since it's a negative, it's going to be graphed on the left side. Okay, and it's going to pass through the pole. So if the radius is 2, the diameter is going to be 4. So I know that it's going to pass here, and I need to go left 1, 2, 3, and 4 units. This is my diameter, so this will be my center, right? If I try to graph 1, 2, it should be like around here. 1, 2, it should be like around here. All right, so let's graph the circle. So the circle should be something like this, right? The circle should be something like that. That is the graph for negative 4 cosine of theta. If it was positive, it will be basically the same circle, but drawn to the right side, right? But we don't have that. We have a negative 4 cosine of theta. Okay, that's how you draw circles. Every time that you have r equals something times sine of theta, or r equals something times cosine of theta, then you will have circles, all right? So you will have circles. Remember that. This is everything for this video. I'm going to leave in the comments, I'm going to pin a comment with a link in which you can go and practice some equations for this part of graphing polar equations. After this, don't miss the next video about how to graph older type of polar equations that are called, the graphs are called cardioids or lemmasons. Right, so do not miss on that video to learn how to graph those. See you in the next one.